climate oscillations of the Quaternary, Moraines to Microfossils. UGC Net Anthropology. Unit 5. Part 5.5. Welcome to AnthroNet Academy, a study aligned with the UGC Net Anthropology syllabus. Dear learners, please subscribe to my YouTube channel, AnthroNet Academy, to keep me motivated to create more content for you. Don't forget to like, share, and hit the subscribe button. And make sure to click the bell icon so you never miss an update. Gift on 1,000 subscribers. AnthroNet Academy is excited to announce a special gift for our viewers once we reach 1,000 subscribers. Why subscribe? We're bringing you the latest current affairs in anthropology, curated specifically for competitive exams. Stay updated with exam-oriented analysis, expert insights on recent developments, daily/weekly current affairs tailored for anthropology. Special surprise gift awaits all our early supporters once we hit 1K. Don't miss out. Subscribe now, be a part of our growing community, and take your anthropology preparation to the next level. Hit the bell icon so you never miss an update. AnthroNet Academy, your gateway to anthropology excellence. Evidences of Quaternary climatic change. The Quaternary Period, 2.6 million years ago to present, is marked by repeated glacial, interglacial cycles. Understanding these climatic oscillations relies on multiple lines of evidence: landforms, sediments, biological remains, and geochemical proxies. 1. Moraines. Nature: accumulations of till, unsorted debris deposited by glaciers. Types: terminal moraines mark the maximum extent of glaciers. Recessional moraines indicate pauses during retreat. Lateral moraines deposited along valley sides, recording ice thickness. Ground moraines widespread deposits left as ice melts. Climatic value. Extent and volume of moraines reconstruct glacial maxima and minima. Chronology, using radiocarbon, OSL, cosmogenic dating, ties glacial advances to specific climate events. Examples: Wisconsin moraines in North America, Himalayas, European Alps. 2. Varves. Definition: annual sediment layers in glacial lakes. Summer layer: coarse, light-colored silt, high meltwater input. Winter layer: fine, dark clay, lake frozen, low input. Climatic significance. Act as annual climate calendars. Thickness indicates seasonal variations. Used to date deglaciation events with year-by-year precision. Examples: Swedish Varve chronologies, used by De Geer, provide records of retreat of Scandinavian ice sheets. 3. River terraces. Definition: step-like benches along valley sides representing former floodplains. Formation: glacial periods low sea level rivers in size valleys. Interglacial periods higher discharge and sediment supply aggradation. Climatic significance. Terrace staircases record alternating phases of incision/aggradation tied to glacial cycles. Examples: Thames Valley, UK, Ganga Basin, India. 4. Loess deposits. Nature: wind-blown fine silt, often yellow-brown, accumulated downwind of glacial outwash plains. Climatic value. Less layers: cold, dry, windy glacial climates. Paleosols, fossil soils, interglacial warm and moist phases. Examples: Chinese Loess Plateau, continuous quaternary record, Loess of Central Europe, Rhine Valley, Danube Basin. 5. Sea level changes. Process. Glacial maxima sea level drops, up to 120 to 130 m lower, as water is locked in ice. Interglacials sea level rises as ice melts. Indicators: raised beaches, drowned river valleys, rias, submerged terraces, coral reef terraces. Climatic value: global eustatic, changes directly reflect ice volume. Examples: Barbados coral terraces, Sunda shelf, submerged during Holocene transgression. 6. Beach sequences. Definition: ancient beaches preserved as terraces. Climatic significance: represent still stands or slowdowns in sea level rise during interglacials. Correlated with marine isotope stages, MIS. Examples: uplifted coral/beach terraces in Hawaii, Barbados, and Mediterranean coasts. 7. Deep sea cores. Nature: marine sediment cores were covered by drilling ocean floors. Key proxies: oxygen isotope ratios, delta superscript 10/delta superscript 10 in foraminifera. High delta superscript 10 equals glacial more superscript 10 locked in ice sheets. Low delta superscript 10 equals interglacial melted ice returns superscript 10 to oceans. Ice rafted debris evidence of iceberg transport. Carbonate content productivity and dissolution linked to climate. Significance: provide continuous global records spanning millions of years. Used in SpecMap and LR04 stacks for global climate correlation. Examples: North Atlantic cores showing Heinrich events, massive iceberg discharges. 8. Fluviatile deposits. Nature: river sediments, gravels, sands, silts. Climatic significance: coarse gravels high energy, glacial meltwater rivers. Fine sediments interglacial, low energy deposition. Terrace gravels often tied to glacial periods. Examples: Danube gravels, Ganga alluvium showing late Quaternary monsoon variability. 9. Palynology, pollen analysis. Method: study of fossil pollen preserved in lake sediments, bogs, and soils. Climatic value: different plants produce distinctive pollen vegetation reconstruction. Shifts between tundra, steppe, forest assemblages reflect glacial, interglacial cycles. Examples: European pollen diagrams, e.g., La Grande Pile, France, North American Great Lakes region. 10. Paleontology, fossil evidence. Macrofauna. Cold-adapted species, mammoths, woolly rhino, reindeer, indicate glacial phases. Warm-adapted species, hippos, elephants, indicate interglacials. Microfauna. Foraminifera, diatoms, ostracods in marine/lake sediments respond sensitively to temperature and salinity. Flora. Plant macrofossils, seeds, leaves, complement pollen data. Examples: extinction of megafauna at Pleistocene-Holocene transition linked to warming and human activity. Synthesis. Geomorphological evidence, moraines, terraces, loess, beaches, direct imprints of ice and water. Sedimentological evidence, Varves, sea cores, fluviatile deposits, high-resolution records of processes. Biological evidence, pollen, fossils, ecological responses to climate. Geochemical proxies, oxygen isotopes, quantitative global ice volume records. Together, these provide a multi-proxy reconstruction of quaternary climate, confirming cycles of glaciation and deglaciation governed largely by Milankovitch orbital forcing, amplified by feedbacks, ice albedo, CO2. Comparative table, evidences of quaternary climatic changes. Evidence nature/definition climatic significance examples. Moraines glacial till deposits, terminal, recessional, lateral, ground, mark extent, thickness, and retreat/advanced stages of glaciers direct evidence of glacial maxima/minima Alps, Europe, Himalayas, Wisconsin and moraines, N. America. Varves annual sediment layers and glacial lakes, summer equals coarse, winter equals fine, year-by-year climate record. Varve thickness indicates meltwater intensity, temperature proxy. Sweden, De Geer's Varve chronology, Finland. River terraces step-like former floodplains cut by rivers alternating incision, glacials, and aggradation. Interglacials correlate river activity with climate oscillations. Thames Valley, UK, Ganga Basin, India. Loess deposits wind-blown silt from glacial outwash plains. Loess equals cold/dry glacial phases. Paleosols equals warm/moist interglacials. Long-term climate cycles. Chinese Loess Plateau, Danube and Rhine valleys. Sea level changes. Fluctuations of global sea level tide to ice volume. Glacial maxima sea level drop up to 120 m. Interglacial sea level rise. Global ice volume indicator. Drowned valleys, Reus, fjords, Sunda Shelf, Barbados terraces. Beach sequences. Ancient raised beaches or terraces represent former shorelines tied to interglacial high stands. Correlate with marine isotope stages. Barbados coral reefs, Hawaiian terraces, Mediterranean. Deep-sea cores. Marine sediments with microfossils and isotopes. Oxygen isotope ratios, delta superscript 10/delta superscript 10, show global ice volume. IRD layers mark iceberg discharges. SpecMap/LR04 records. N. Atlantic Heinrich events. Fluviatile deposits. River gravels, sands, silts. Coarse gravels equals glacial meltwater floods. Finer deposits equals interglacial low energy conditions. Ganga floodplain, monsoon variability, Danube gravels. Palynology. Fossil pollen preserved in sediments/peat reveals past vegetation. Shifts between tundra, steppe, forest assemblages reflect glacial. Interglacial cycles. La Grande Pile, France, Great Lakes, USA. Paleontology. Fossil fauna and flora, macro plus micro, cold adapted fauna, mammoth, reindeer, equals glacials. Warm adapted fauna, hippo, elephant, equals interglacials. Microfossils track temperature/salinity. Megafauna extinctions at Pleistocene, Holocene boundary, foraminifera records in oceans. Thank you for watching. Stay connected.